Hi everyone, myself Arun Kumar from SNS College of Technology in the Department of EC. In this video, we are going to see about steady state errors in time response analysis. So these are the slides we are going to see in this video: introduction, static error constants, second order systems, activity, and followed by assessments. Understanding the steady state errors of the systems. The steady state error is the problem which will be indicated based on the transfer function of the systems, because the transfer function system itself clearly define the error of the systems. Sometimes it may not be known about the users because they may not be depend on open loop and closed loop systems. So these are the challenges, and we need to consider and calculate the steady state error of the corresponding transfer function of the system. Then only we can able to transmit the information without any failure conditions. Definition. So this is the transfer function of the system. So input is R of S and E is the error of the system, and GFS is transfer function of the system, and CFS is the output of the system. Suppose if you are having any error of the system means, then it will be indicated as a E of S, error of the system. So that we need to calculate the corresponding error value, and then we can able to transmit it again. So the closed loop transfer function can be clearly defined by C of S divided by R of S equal to G of S divided by 1 plus G of S into H of S. Suppose if you are having value in feedback means, the same value has been calculated by using this formula. So here don't have any value, so I won't mention any value here. So the next one is E of S. The error of the system can be calculated by 1 by 1 plus G of S into R of S. So that we need to calculate the value of the input as again for this error of the system. The next one is steady state error. So here the E of S is indicate about the error of the system. Then we need to represent the errors can be in steady state response by multiplying S and putting the value as limit S equal to 0, so that we can able to get the steady state error of the corresponding transfer function of the systems. And next one is static error constants. While moving or generating the values of the transfer function, it may be depend on three factors. One is position and velocity and acceleration. These three factors define the systems based on the moving or generating the function of the systems. Especially it can be based on type 0 system, type 1 system, and type 2 systems. Type 0 means 1 by 1 plus k position kp, and next one is type 1 is equal to 1 by k, so 1 by k velocity, 1 by kv, and next type 2 system means 1 by ka acceleration. So let me see how these systems has been represented for remaining of the systems. And second order system for position error constant. The position error constant doesn't have any values because it is a type 0 system, so we won't put S value here, so that the value become limit S tends to 0 G of S. And the static error constant can be calculated by 1 by 1 plus kp, so like this. So these are all the system functions of the position error constant. If it is parabola, then it will be indicated as waveform like this, like diagonal and flat. So these are all the default constant value for the positions. And next one is velocity error constant. So in velocity error constant is based on type 1 system, so the equation become S into G of S, so S power 1, because it's a type 1 system, so we are choosing here as S power 1, and the same value 1 by k they are given, so the same value has been calculated as A by kv. Velocity V means velocity, k is a constant, and the corresponding representation of the diagonal flat 0 value has been the default conditions as velocity is given as these waveforms. And next one is acceleration error constant. So acceleration is comes under type 2 system. So here they are included about S square into G of S. Limit S tends to 0, S square into G of S, because the S square shows that the second order system of the type 2 systems. next one is the corresponding error, steady state error is 1 by Ka acceleration. So they are given about A by Ka here. So and moreover they are giving a flat and zero default conditions for the acceleration is given by. If it is change anything means then the value or the corresponding graph will be changed based on the given inputs conditions. Mind mapping, so we need to know about the constant and error constants and input and performance. So from this mind mapping techniques, activity, here the activity is given as inside a control system who causes the errors. Role assigned for 5 to 6 students per group. The scenario given by type 0 system with step input. Scenario 2 is given by type 1 system with ramp input signals, so that we can able to calculate the role play conditions, and they are making their own preparation in the classroom itself. Assessment, steady state error is defined as error at the initial instant, error during the transient state, error as the time approaches infinity, and maximum error in response. The answer become error as time approaches infinity, because once if you are find out the values, then it will be very easy. And second question is steady state error mainly depends on transient response, type of the input signals, initial condition, sense or noise. The answer is type B, type of input signal. It is only define the clear state conditions of the systems. These two references I have taken for this video. Thank you.